Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0657, indicates a malfunction in the power supply circuit for the Powertrain Control Module, PCM, in the Honda Accord manufactured between 2017 and 2023. The PCM is critical in managing engine functions and ensuring that data from various sensors is accurately processed for efficient vehicle operation. A fault within the power supply circuit can lead to significant vehicle performance issues and incorrect sensor readings. Identifying the root cause of this DTC involves a systematic approach to troubleshooting, starting with verifying the presence of the DTC using a Honda Diagnostic System, HDS. It's crucial to clear the DTC and observe whether it returns, indicating a persistent issue. Proper exploration of potential causes and subsequent actions can restore the circuit functionality. Always refer to specific repair guides or service bulletins for nuanced troubleshooting steps tailored to the Accord model and year. The DTC P0657 indicates a malfunction in the PCM power supply circuit. In this instance, the PCM is responsible for processing information from various sensors and controlling the engine's performance and efficiency. The PCM is typically located in the engine compartment or near the cabin area, depending on the vehicle's design, and it connects to multiple wiring harnesses. Its operation is integral to vehicle functionality, as it influences engine timing, fuel delivery, and overall vehicle response. Malfunctions in the power supply circuit can stem from several issues, including bad connections, short circuits, or damaged components. To effectively troubleshoot this code, an understanding of the exact components involved, including the relay circuit board and associated fuses, is crucial. Several potential causes can trigger the DTC P0657. Corroded or loose connections in the relay circuit board or the PCM can disrupt the power supply, leading to malfunctions. Specifically, inspecting the condition of these connections can reveal issues affecting operational integrity. A faulty relay circuit board can also cause power supply disruptions, as it plays a vital role in managing electrical signals within the circuit. Additionally, a blown fuse A13 could indicate a short circuit or excessive current draw, necessitating thorough inspection and potential replacement. Lastly, assessing for short circuits in the associated wiring is imperative, as damaged wires can lead to current losses or unintended signals, further complicating the circuit's functionality. The symptoms associated with DTC P0657 can significantly affect vehicle performance and driver experience. Common indicators include engine performance issues, such as stalling, hesitation, or reduced power, all of which can undermine driving confidence. Additionally, the presence of warning lights on the dashboard, particularly the check engine light, serves as a clear signal that the vehicle requires immediate attention. These warnings can often prompt a driver to consult a mechanic or conduct further troubleshooting. In some cases, power loss may occur due to the PCM's inability to correctly process input from various sensors, leading to an unpredictable driving experience. Recognizing these symptoms can prompt timely repairs, mitigating further damages. The first step in troubleshooting DTC P0657 involves verifying the presence of the trouble code. Begin by turning the vehicle to the on mode without starting the engine, which enables the vehicle's electronic systems for diagnostics. Next, utilize a Honda Diagnostic System, HDS, to clear the DTC memory. This step resets the system, allowing it to note any fresh occurrences of the error. After clearing, start the engine and recheck for any pending or confirmed DTCs using the HDS. If the DTC P0657 is still present, it confirms the malfunction is consistent. This step is crucial since it ensures the technician only troubleshoots active issues, focusing on real-time data rather than intermittent errors that might resolve spontaneously. In the second troubleshooting step, turn the vehicle to the off-lock mode to prepare for further examination of the relay circuit board. The relay circuit board is essential for managing power distribution within the PCM power supply circuit. Carefully remove the relay circuit board to assess its integrity. Testing can be performed using a multimeter to check for continuity and operational effectiveness. If the relay circuit board is found to be faulty, it must be replaced to restore proper circuit function. Ignoring this step may lead to further complications, as a non-functional relay can prevent the PCM from receiving the necessary power supply, leading to persistent DTCs and performance issues. The third troubleshooting step focuses on checking fuse number A13, a critical component in the power supply circuit for the PCM. It's paramount to inspect the condition of this fuse closely, as it protects the circuit from excessive current and potential damage. If the fuse is intact, this indicates that the circuit safety features are functioning correctly, and you can proceed to the next troubleshooting steps. However, if the fuse is blown, this is indicative of an underlying issue within the circuit that necessitates further investigation. Problems could arise because of short circuits or excessive loads, and the action plan will involve addressing these issues comprehensively to re-establish functionality. In the fourth troubleshooting step, you will need to examine the possible failure area related to the +B IGP line. Start by removing the blown number A13 fuse and subsequently disconnecting the injector relay to isolate the circuit. It is necessary to check continuity between specified test points and the body ground, while ensuring the vehicle is in the off-lock mode. Specifically, you'll inspect the relay circuit board connector, female terminals, number 11, and body ground to verify if there is a continuation of the electrical pathway. If continuity exists, this indicates a short in the +B IGP wire, necessitating immediate repairs, including replacement of the blown fuse to restore circuit integrity. In the fifth step, begin by jumping the SCS, Selected Communication Service Line, with the HDS and allowing a wait time of more than 1 minute. This action prepares the system for continuity checks while ensuring that only one component is disconnected during each test. Continuity should be examined between specified test points. This involves removing parts one at a time, including the PGM FI main relay 2 and the PCM connector A, 50P, to identify which component may be failing. Disappearance of continuity upon removal of any part indicates that it needs replacement. If the problematic part is identified as the PCM, always verify against authorized service information related to the specific DTCs or symptoms for additional troubleshooting insight. The sixth troubleshooting step calls for disconnecting the PGM-FI main relay 2 and PCM connector A, 50P. By doing this, you will be able to inspect the FI main relay outline for shorts more effectively. As previously, continuity is checked between specific test points while ensuring the vehicle remains in the off-lock mode. Specifically, you will be checking continuity from the PCM connector A, 50P, number 8, to body ground. If continuity is present, it confirms a short in the FI main relay outline that must be repaired immediately to restore the correct functioning of the power circuit. If not, this may indicate it's time to replace the relay circuit board, on top of addressing any additional issues. In this seventh troubleshooting step, Start by reinstalling the relay circuit board in its correct position. After that, jump the SCS line with the HDS once again, allowing a wait time of more than 1 minute for the systems to stabilize. Once this is done, disconnect the PCM connector A, 50P, and measure the voltage between specific test points. The intention here is to verify whether you have battery voltage present at the PCM connector A, number 5. If battery voltage is detected, this suggests that the power supply is functioning as expected, allowing you to move ahead in the troubleshooting process. If not, deeper examination of the power supply interactions and connections is necessary to identify underlying issue. The 8th step focuses on determining possible failure areas once again, this time concentrating on the +B IGP line. Disconnect the relay circuit board connector C, 22P, and measure the voltage between the connector C, number 11, and body ground. The expectation here is to find battery voltage present, which would confirm that the circuit is intact. If battery voltage is absent, this indicates an open in the +B IGP wire, necessitating repair work to restore proper circuit continuity. Repairing this connection is essential to ensuring proper voltage is delivered to the PCM, which is necessary for the vehicle's optimal performance. Step 9 involves connecting terminals A and B with a jumper wire. Terminal A is at relay circuit board connector C, 22P, number 13, while terminal B connects to body ground. With these terminals connected, you will need to check for continuity between specified test points, ensuring that the connectors remain disconnected. The goal is to determine whether continuity is established between PCM connector A, number 5, and the body ground. If continuity is detected, this signifies a potential fault in the PCM or related components. In this case, consult authorized service information or consider substituting the PCM with a known good unit for accurate diagnostics. If no continuity exists, then repair any open circuit along the FI main RLYCL between the PCM and the relay circuit board. The final troubleshooting step requires disconnecting the relay circuit board connector C, 22P, once again. Start by jumpering terminals A and B, where terminal A connects to relay circuit board connector C, number 10, and terminal B connects to body ground. Check for continuity between PCM connector A, number 8, and body ground to verify the circuit's integrity and function. If continuity is present, this indicates that the potential issue may lie in the components related to the PCM. As with previous steps, further consultation with authorized service data or replacing the PCM may be warranted. If continuity is not detected, there is an open circuit in the FI main Rayleigh out wire requiring repair to re-establish proper connections. Following the troubleshooting processes and all necessary repairs, it's crucial to conduct a final repair verification to ensure the issue has been successfully resolved. Begin by clearing the DTC from the PCM memory using the HDS to reset the system. Once cleared, perform a test drive or operational check under the same conditions that previously triggered the DTC. Reevaluate for the presence of DTC P0657. If it does not this indicates that the repairs were effective. Lastly, confirm that the vehicle operates normally without any engine performance issues, confirming the power supply circuit to the PCM is functioning properly. This verification step encapsulates the entire troubleshooting effort and ensures the vehicle is safe and dependable. To prevent future occurrences of DTC P0657, establishing a routine preventive maintenance program is highly recommended. Regular inspections of the relay circuit board, PCM, and associated connectors can help identify potential issues before they escalate. Cleaning electrical connections should be part of this routine, as contaminants can foster corrosion, which leads to poor connectivity and malfunctions. Additionally, it's essential to keep the wiring harness intact and free from physical damage or stress that could cause shorts or disconnected wires. Enhanced vigilance in these areas helps maintain the power supply circuit's health, ultimately leading to improved vehicle reliability and performance. The DTC P0657 is a critical error indicating PCM power supply circuit malfunctions in the Honda Accord from 2017 to 2023. Effective troubleshooting is vital to accurately identify and rectify the underlying issue that causes this code. Following systematic troubleshooting steps, from verifying malfunction presence to examining connections, circuits, and components, is essential to restore functionality. After necessary repairs, thorough testing will ascertain that the DTC is cleared and doesn't return, indicating successful vehicle operation. By implementing preventive maintenance strategies, such as routine inspections and ensuring clean connections, owners can minimize the likelihood of reoccurrence, promoting long-term vehicle reliability and performance. Please like and subscribe to the channel. See you next time.